Hello everyone, I am back with another Google interview question, and today's question is to find a subarray out of some array of integers, non-negative integers whose sum is equal to some given value. So in this case we want to find a subarray whose sum is equal to 31, and the difficulty level of this question on a scale of 1 to 10 I would give around 4. So it's a perfect candidate for telephonic interview at Google, and even it may be asked in face-to-face interviews just to set the tone of the interview. The interviewer may ask it as one of the first questions in order to understand how the candidate thinks and approaches a problem, because since it's a easy problem, so the candidate is expected to arrive at an efficient solution for this problem in short time. So, if the candidate is not able to go in the right direction or not able to arrive at a good solution, then it may have a negative impact on the interview. So, it's very important to understand this problem. So, here in this case, we have to find a subarray. So, subarray is different from subsequence in that in subsequence you are allowed to skip levels. You can skip a few elements in between. Only their relative ordering of the elements that we pick from a bigger array has to be there. So this is subsequence, but sub array has to be contiguous. So we cannot skip any element. So this is sub array and this is subsequence. So here our task is to find some sub array. So this makes it easy because we have to just keep two pointers and just expand in one direction and then shrink in one direction, because we are not allowed to skip any element. So if you see here 5 plus 8, 13 plus 6, 19 plus 12 is 31. So in this case this index is 0, 1, 2, 3, 4, 5, 6, 7, 8. So it should print from index 2 to 5. We see that 31 is also present here, so it could have printed 8, 8, that is starting index 8 and last index also 8. But we have to just print the first such subarray. So one of the easiest solution would be to take two indexes and iterate through this array and take all values of I and then j, and see if for any value of I and j is this sum equal to 31. So this subarray is represented by two indices, start index and end index. But this iterating through this entire array would be order n square, because first we will take first index to be 0 and do the same for all values from 1 to end. Then we will advance I to 1 and then the j will be from 2 to end. So this will be n plus n minus 1 plus all the way 1. So this will be n times n plus 1 by 2. So order n square. So can we do better? So our aim would be to arrive at a more efficient solution. So this is our original array, and in the second solution we will start with a window of first element. So our start index will be here and end index will be here at the second element, and or we will keep both start and end here because our window size is 1. So we will see that our current sum is 10, which is less than 31. So we have to expand this window. So we will move the end pointer here. Now our window becomes this, and our new sum is 10 plus 3, 13, and again it's less than 31. So we will move end here, and now it becomes 13 plus 5, 18, still less than 31. So we will move end here. Now it becomes 18 plus 8, 26, still less than here 31. So we will move end here, and now it becomes 32, which is more than 31. So now our window is this. from this to this, and we cannot remove any element from in between because we have to find contiguous array, and we cannot shrink from this side because we just expanded from this side, so we will go back to our previous state. So the only choice is to move this start here. So now start is here at 3 and our window is this one. So now sum is 22, which is less than 31. So we will move end here. So now it becomes 34, again more than 31. So we will move the start pointer here at this point, and our window now becomes this. Now our sum is exactly 31. So we will print these values. So 5, 8, 6, 12. So our program should print 2 to 5, all numbers from 2 to 5. So now let's write down the code for this. So our function should look like this. It should return void, and we will name it subarray sum, which will take one integer array, non-negative, the size of the array, and the sum which we want to calculate. So we will initialize the current sum to be the first element of the array. Then we will take two indices, start and end. So if current sum is equal to sum, then we will print out the range. And we will return from the code because we want to just print the first subarray. If it's not equal to sum, then it will be either greater than sum or less than sum. So if current sum is greater than sum and the start index should be less than end index, then if sum is greater, we will advance the start pointer towards right and subtract that value from the current sum. So whatever value was present at the start index, we will subtract from sum and then move the start to next pointer. Else, that is current sum is less than sum, so we will add the end pointer. So whatever end index is pointing to, we will add that value and then increase the end pointer. And if it did not find any sum, then it will simply exit out of this loop. But if it finds one subarray, it will print the range. So let's run it on our example. and our target sum was 31. So it should print this 225. Now let's run it. So it's saying no matching, function call to subarray sum. So first is, okay, this, so it prints 2 to 6. So I we are, so whatever value we take off the end, so whatever end is pointing to, we add to the sum and then add one, increase the I by end by 1. So actually current sum does not include the updated value of end. So it takes the previous value of end and then updates end. So which we should print end minus 1. Now it correctly prints. Now let's try on some other values. Some other cases like 31 is in the beginning, then it should print 0 0. Yes, it does. Now let's take some more examples. So it should print 1 1. Yes, now 21, 11 and 20, it should print 0 to 1. Yes, because this sum of these two is 31. So now it's working as expected. So it was a pretty easy question from Google's point of view. So keep practicing it, and it's very important to build the algorithmic thinking process. So these questions are on the easier side, and you should be able to think about it and arrive at the solution. And keep watching my channel. I will be back with some more Google interview questions, and all the best for your Google interviews. Thank you.